Hi guys, did a video manually pulsing this pulse motor using an RFID tag coil. I'll put a link in the video description so you can go to that video and see what I'm talking about. But an RFID tag is basically a flat coil with a little bit of circuitry on it that when you scan it with a scanner, it activates or it generates current in the coil that activates the little circuit that then sends a signal back to the detector so you know what that item is connected to. And it's under that bit of cardboard there. It's just a flat coil. And I was pulsing this pulse motor with it manually. I didn't set up a proper pulse circuit with it. I just had it sitting on here. And I was using, I was actually using a LiPo battery or lithium ion battery because I happen to have one handy. So I jammed the wires in there, tapped them on, and if you get the timing right, better than that, let's try that again. Oh, rubbed against the bottom then, that was no good. Got to get it go far enough round so you can catch the next one. No. All I'm doing is just connecting the wires together briefly to give us a pulse of magnetism. No. Well, you can see the general idea. I'm not going to spend time trying to get it right. Anyway, chatting to Lid Motor, we were talking about various things that you could do with items that have got coils in them. And that reminded me of a video I did 2013, 2014 sort of time with my grandson with just a straight piece of copper wire. Well, I did have a coil, but I also had a straight piece. And we're making magnets jump away from the straight wire. It doesn't need to be a coil. Magnetism or a magnetic field is generated round any conductor. The reason you use a coil is it magnifies the effect. So I thought, how about if we do away with that for a minute. This is the remains of a solar rocker. Got a magnet on the bottom and it rocks nicely. So I've got a lead here. I will, before I connect it to the battery, I'll tape it to the table. So that's just a straight piece of wire. Put him on top, connect up the power, which at the moment is going nowhere. There's the other end of it. But if I just tap it on the other end of the wire, the other end of the red wire, briefly, because we don't want to blow up my battery. So we can see that we're generating a magnetic field that's making the solar rocker rock. So the next thing is, can we put that on here, well, the answer is no, because I've already tried it. There isn't enough clearance between the top of there and the bottom of the magnet. So if I use this, which is just another thing that I've 3D printed, it happens to be just a little bit thinner. This is blue tack, if you've never seen blue tack before. This is not an ideal way of doing it, but it will give you an idea of what we're talking about. And if I tape that there, I think we've got the clearance now. We might have a bit too much clearance, but let's see what we can do. Bring that round a bit closer. Yeah, I think we've got a bit too much clearance. So it's being repelled just by the magnetic field generated around that wire when we put current through it. Obviously not as strong a kick as we were getting from the coil. So I don't think we're actually going to be able to do a complete rotation with this. Although if I try and adjust the height of that a little bit, what else can I use? It's got to be non-magnetic, otherwise that messes everything up. How about if that bit of wood, would that fit in there? Oh, that's so frustrating. That would almost fit in there. But that's going to be too high anyway, isn't it? Maybe. No, still a bit too much clearance there. We're not going to get a big enough spike or push to get it all the way around. Could try more current. Or we could just say we've got the principle, just not quite enough power. How about now with a bit of blue tack under it, just to raise it up that little bit more. That's Nanny just going to bed. Yeah, in the background there. No, I don't think we're going to get a big enough kick to actually send it all the way around. That's a bit too close. No, we're not going to get enough kick to send it all the way around. But you can see what I'm talking about. We don't necessarily need a coil, but a coil magnifies the effect. But we do get a magnetic field around a wire with current flowing through it. That'll do. That was just to demonstrate the principle. Current flowing through a wire generates a magnetic field. And if you want to do the maths on it and try and work out how much field is generated by however many volts, well, you're welcome to it. I don't do the maths. I just play with it and see what happens. And it's not a good idea to be shorting out a lithium-ion battery like that. That'll do. Thanks for watching. That was just a bit of fun. Clearly this is slightly out of balance. Thanks for watching. If you want more information, check down below in the video description. If you like this video, you might like this one up here. And if you want to subscribe, you can check out my channel over here. Up here is my latest video on my channel, and down here is a video playlist associated with the video you've just watched. Thanks again for watching.